Let's do question 1. So here we find the derivative of f of x at x equal to pi by 2. So let's find the derivative of f of x, which is written as f prime of x. And so this equals, notice that 2a is a constant and negative 5 is also a constant. So therefore the derivative of constant is going to be 0. And so f prime of x equal to 0. And this means when we plug in x equal to pi by 2, that is f prime of pi by 2, this is once again going to be a 0 because this f prime of x is independent of x. So the derivative of f of x at x equal to pi by 2 is 0. Now let's do question 2. Here we find the derivative of g of x at x equal to 5. So we find the derivative of g of x written as g prime of x, and this equals, we should find the derivative of 2x squared. So first I put this constant 2 and then find the derivative of x squared, which is 2x when we use the power rule, and derivative of negative 1 is 0, so we put 0 here. And so basically this equals 2 times of 2x is 4x, and this is the derivative of g of x. Now we should find its derivative at x equal to 5. So we plug in x equal to 5 into the derivative function. Therefore it becomes g prime of 5, and this equals 4 times of 5. Replace x by 5. So 4 times of 5 is 20. So therefore the derivative of g of x at x equal to 5 is 20. We now find the derivative of h of x at x equal to pi by 2. So let's write this as h prime of x. And to find the derivative of 5 sine x times cosine x, we should use the product rule. So let's consider this as first term and cosine x as the second term. So I write the first term now, that is 5 times of sine x, and then multiply with the derivative of cosine x, which is negative sine x. Now I write the second term, that is cosine x, and then multiply with the derivative of 5 sine x, which is 5 times of cosine x. And so let's simplify this. We have 5 times of sine x times negative sine x, which equals negative 5 sine squared x, plus we have cosine x times 5 cosine x equals 5 times of cosine squared x. So this is basically the derivative of h of x, which is h prime of x. Now we have to find its derivative at x equal to pi by 2. So let's plug in x equal to pi by 2 into h prime of x. So therefore it becomes h prime of, replace x by pi by 2. And so this equals negative 5 times of sine squared of x. So it is sine squared of, replace x by pi by 2, plus 5 times of cosine squared, replace x by pi by 2. So it is cosine squared of pi by 2. And so this equals negative 5 times of sine squared of pi by 2 is basically sine pi by 2 quantity squared. And similarly, cosine squared pi by 2 is basically 5 times of cosine pi by 2 quantity square. Now we know that the value of sine pi by 2 equals 1. So therefore this becomes negative 5 times of 1 square plus 5 times of, and the value of cosine pi by 2 is 0. So therefore this becomes 5 times of 0 squared. And so this is going to be 0. And here we have negative 5 times of 1 squared is 1, and negative 5 times 1 is negative 5. So therefore we found that the derivative of h of x at x equal to pi by 2 equals negative 5. Let's do question 4. Here we find the derivative of I of x equals 3 times of tan inverse of x at x equal to 0. So let's find the derivative of I of x, which is written as I prime of x. And this equals, we have the constant 3, which I write as it is. And then we find the derivative of tan inverse of x. So according to the standard derivative formula, the derivative of tan inverse of x is 1 over 1 plus x squared. So basically this becomes 3 times of, or 3 divided by 1 plus x squared, and this is the expression for the derivative of I of x. Now we find the derivative at x equal to 0, so we should plug in x equal to 0 into the derivative function. So therefore this becomes I prime of 0, and this equals 3 divided by, replace x by 0, so it becomes 1 plus 0 squared, and this equals 1 plus 0 square is 1, so it is 3 over 1 equals 3. So this is the derivative of I of x at x equal to 0. Let's do question 5. Here we find the derivative of g of x, which equals e power x times natural logarithm of x at x equal to 1. So I write j prime of x, and this equals, here we should apply the product rule. That is, we consider this as first and natural logarithm of x as second. So I write the first function as it is, and then multiply with the derivative of the second, which is the derivative of natural logarithm of x, which is 1 over x. Now I write the second function, that is natural logarithm of x, and then multiply with the derivative of the first, which is the derivative of e power x equals e power x. So now we can find this derivative at x equal to 1. So we replace x equal to 1 into the derivative function, and so this becomes j prime of 1 equals, replace all x by 1, so it becomes e raised to the power of 1 divided by 1 over 1 plus natural logarithm of x is replaced as 1 times e raised to the power of 1. And this is 1 by 1 is 1, and e power 1, you can write this as e, plus natural logarithm of 1, we know that its value is 0, and 0 times e power 1 is e. So therefore the second term gets cancelled, and so we get the value as e. This is e, and therefore we say that the derivative of this function at x equal to 1 is e. We now find the derivative of k of x at x equal to pi by 4. So here we have the function k of x equals 3x squared times cotangent x divided by e power x. So basically this is a quotient function. So to find its derivative, we have to apply the quotient rule. So let's do that. I write down k prime of x, and this equals, I first put the denominator function, that is e power x, multiplied with the derivative of the numerator function, which is 3x squared cotangent x. So to find this derivative, we should apply the product rule. So let's consider this 3x squared as the first term and the cotangent x as the second term. So I write the first term now, so which is 3x squared, and then multiply with the derivative of cotangent x, which is negative of cosecant squared x. This is according to the standard formula of derivative of cotangent x, plus we now put cotangent of x, then multiply with the derivative of 3x squared, which is 3 times of derivative of x squared is 2x. So basically this is 6x. I can change this to 6x. And then according to the quotient rule, we put minus. Now this time we put the numerator term, that is 3x squared cotangent of x times the derivative of the denominator expression, that is the derivative of e power x, which equals e power x, and this should be all over the e power x quantity square, that is the square of the denominator term. Now let's simplify this and substitute the value at x equal to pi by 4. So I write k prime of x, and this equals, notice that we have e power x in both terms, so we can factor the e power x, and so when we do that, we get e power x times of, let's multiply this term, which is negative 3x squared cosecant squared x, and this term is, I can write this as 6x times of cotangent of x. We then have a negative, and I write this term, that is negative of 3x squared cotangent of x. So we get this expression after we factor the e power x, and this should be all over e power x quantity square. Now we see that we can reduce this e power x. This is 1 power of e power x with this 1 power of e power x. So basically in the denominator we now have only e power x. Now we can plug in the value of x, that is x equals pi by 4, so that we find the derivative at x equal to pi by 4. So therefore this becomes k prime of pi by 4, and so this equals we have negative 3 times of x squared, which is pi by 4 quantity squared, times cosecant squared pi by 4 plus 6x. In fact, we can factor the cotangent of x. So let me factor the cotangent of x. So I write cotangent of, I can replace this x by pi by 4. Then when we factor the cotangent of x, we will be left with 6x, which is 6 times of pi by 4 minus 3x squared. So replace x by pi by 4. So it becomes 3 times of pi by 4 quantity squared. And this should be all over e raised to the power of, replace x by pi by 4. So it is e power pi by 4. Let's simplify this. So this equals negative 3 times of pi by 4 quantity square is pi squared over 16. And then cosecant squared pi by 4. This can be written as 1 over sine squared pi by 4. We know the value of sine pi by 4, which is root 2 over 2. So this is root 2 over 2 quantity squared. And so this becomes 1 by root 2 square is 2, and 2 square is 4. So this is basically half. So 1 divided by half equals 2. So therefore cosecant squared pi by 4 equals 2, which I replace here, and then multiply with, we now have a cotangent of pi by 4, so which is 1 over tan pi by 4, and tan pi by 4 is 1, so basically this is 1 over 1, which equals 1 times of 6 times of pi by 4. I write as 6 pi by 4 minus 3 times of, this is pi squared by 16, and this is over e raised to the power of pi by 4. Let's continue simplifying. So this equals, we now have 3 times of 2, which is negative 6 pi squared by 16, plus we just have factor 1. So let's put this as 6 pi by 4 minus, this is 3 pi squared over 16 divided by e raised to the power of pi by 4. Now we see that we have this common denominator 16 here, 16 here, sorry about it, 16 here, but not 16 here. Instead we have 4 here. So we can rewrite this 6 pi by 4 as constant as the denominator 16 by multiplying and dividing by 4. So therefore this becomes 6 times of 4 is 24 pi by 16, which I'm going to write here. We have negative 6 pi squared by 16 plus 24 pi by 16 minus 3 pi squared by 16, and this is over e raised to the power of pi by 4. And so we have a common denominator of 16 for the numerator fraction. This means we can write this as negative 6 pi square plus 24 pi minus 3 pi square, and this is over e raised to the power of pi by 4. Now we see that negative 6 pi square and negative 3 pi square equals negative 9 pi square. So I put this 24 pi minus negative 9 pi square, and this is divided by 16. and this is the numerator term, and this is over e raised to the power of pi by 4. And this can be written in simple form as 24 pi minus 9 pi squared. This is divided by 16 times of this one, and this term will get multiplied. So e raised to the power of pi by 4. And so this is the expression for the derivative of k of x at x equal to pi by 4. That is basically this can be written as k prime of pi by 4. We can evaluate its numerical value by plugging this into the calculator. And when we do that, we get an approximate value of negative 0.3827. This is approximated to four decimal places. So this is the approximate value.